Yeah, we got a fan that won't go. And it's summertime, you gotta have a fan. Now what happened to this old puppy? Apart from the dirt. Here's the answer. That there, that's a resistor. Up the back, see how it's burnt? It's possible, just possible, that there's a bad joint there now. But I don't think so. I think it's good enough to conduct. And so there's something else wrong. And you look here, this switch. When you touch the switch on the outside of the, the only switch that there is to control, the only operator serviceable thing, it just pushes, closes the contact in there, which tells this chip to do something. Okay, and the chip only has, depending on where you have these dip switches set, and that's something that we're not even worth talking about right now. But there's a series of dip switches here that you can set. Of course, I don't have the book, so I couldn't explain any of that to you. But once you're done there, you have the option of pushing this button over here, this little round thing. And there's 4 settings. There's off, and 1, 2, and 3. Just runs the motor at different speeds. And that's all controlled by this chip. So somehow, we could bit bang that thing and probably get it to turn on at some speed, but we're not going to do any of that kind of stuff. I'm looking at the board, like this board here probably operates on 1 or 2 volts or something. It's got there's probably the power supply on this side. There's 4 rectifiers down in there. Oh, and the capacitors look good. There are some good parts about this, but it isn't worth playing with. So we're just going to disconnect this selection mode and wire it directly. So when you plug it in, it'll blow air around. That's all for now. Alright, so that's not part of the game anymore. And I just marretted the ends together. Okay. So it's a 1-speed fan, on and off. You can tell that motor's running, maybe. I don't know, can you? Vibrating everything. Throwing dirt around. I'll put the fan on there and we'll see what it'll do. See, if I turn it on and it bounces around, falls on the ground, and damages it, then where am I going to be? Let's see what happens. Ah, look at that! Whoa! Whoa, whoa, whoa. Oh, she's a fire. She's an ultralight. There is one thing you could do is, since we buggered up the RPM control, we could restrict the air inlet on the back side here. The RPM would climb even higher, but it would push less air, possibly. So I'm assuming that they can run that thing at full bore all the time. So let's turn it on and let it run for a few minutes, if the motor overheats. This time we're going to try measuring with the clamp meter to see how many amps it's drawing when it's running. I ran it for about 5 minutes. It didn't get hot or anything. And we're running it through this, I don't know what these are, monculoids. I think it'll kick out if you try and draw more than about 3 or 4 amps through it. It's already, when I turn it on, it's running the fluorescent lights in the shop there. But here we go, we'll turn it on and see what happens. .45, less than 1.5 amps. That's pretty good. You can run it like that all day. So as I work on this fan, I'm having flashbacks about some of the problems. I recall people asking me to do something about it. All that plastic that was on here was meant to hold it from flopping around. These adjusters on here, they only last so long, and then they can't tighten them anymore, and the thing just flips around, and it either blows up at the ceiling or blows behind the other way. It's useless. So they were winding string and plastic junk around it to hold it, but so I put some wire on either side. No, the pitch of it's not adjustable anymore, but it won't change. It'll always point in the direction that you pointed in the beginning. So it's good now. It'll be back in operation next week for the heat wave. That's all for now. Hope you enjoyed watching this crap.